Do you remember this slide in the previous voice thread on factoring? You're going to keep on using this chart. Whenever you need to factor, always ask yourself the question, is there a GCF? If the answer is yes, you follow these steps. If the answer is no, ask yourself the question, how many terms? If there are two terms, the method will be the difference of two perfect squares. And that's what we're going to learn in this voice thread. You should already know how to manipulate algebraic expressions. And by that I mean you should know how to add, subtract, multiply, and divide expressions that contain algebra. So in this voice thread, you're going to learn what a perfect square means because you must recognize that whenever you decide what factoring method to use. So it's important you know what a perfect square is. Then we're going to look at the procedures for following the difference of two perfect squares factoring method. And I will have several examples that you can practice with. First thing to understand is, what is a perfect square? The following values that you see on the board are all perfect squares. But do you know why they are all perfect squares? 9 is a perfect square because 3 times 3 is equal to 9. 81 is a perfect square because 9 times 9 is equal to 81. 25 is a perfect square because 5 times 5 is equal to 25. X squared is a perfect square because x times x is equal to x squared. Y to the fourth, y to the power of 4 is a perfect square because y squared times y squared is equal to y to the fourth. 36 w to the power of 16 is a perfect square because 6w to the power of 8 times 6w to the power of 8 is equal to 36w to the power of 16. So these numbers are all perfect squares because when you factor them, the factors are identical. Now, along with understanding what a perfect square is, it is important you understand what we mean by the square root. Do you know the square root of each of these values? And do you know why? Would you try that? And then I'll explain it for you. The square root of 9 is equal to 3. Square root of 81 is equal to 9. Square root of 25, 5. Square root of x. Square root of y to the fourth, y squared. And the square root of 36w to the power of 16 is 6w to the power of 8. Finding the square root of a number is the inverse operation of squaring that number. And that number would be the perfect square. So the perfect square here is 9. When I want to find the square root of 9, I am looking for what am I going to multiply by itself to give me 9? And that number would be 3. So the square root of a number is the number that gives what you multiply by itself to give that perfect square. Square root of 81 is 9 because you're multiplying 9 by itself to give to you 81. And you have the other examples here. This is language you need in order to factor the difference of two perfect squares. I'd like you to look at these examples and I'd like you to think about What do you notice about these four examples? What's the same? What's different? What are you describing? What operation? Think about that. What do you notice? For each of these examples, we have the product of two binomials. By product, I mean I'm multiplying. By binomials, I mean two terms. Notice I have two terms times two terms for each of these examples. Notice the first term in each binomial is identical. So here, these are identical. These are identical. The first term in each binomial, they are identical. Also, the second term in each binomial is identical. For example, here I'm 5, 5, 2, 2, 3, 3, D, D. In one factor, and by the way, these are factors because we have the product. In one factor, there's an addition. In the other factor, we have subtraction. Notice here, plus, minus, plus, minus, plus, minus, plus, minus. That's a phenomenon that is important to understand for the difference of two perfect squares. Go to the next slide, and you'll have another task. So your task now is to simplify. You have a binomial times a binomial. Remember, a binomial times a binomial, you're going to use the FOIL method. Are you familiar with FOIL? FOIL represents I multiply the first terms in each of the binomials. The O represents the outside terms. I multiply the outside terms. The I represents the inside terms. I multiply the inside terms. And the L represents that you multiply the last terms. Would you please FOIL each of these expressions, and you can correct them on the next slides. X times x is x squared. Our outside terms, x times -5 is -5x. Our inside terms, +5 times x is +5x. And our last terms, +5 times -5 is -25. And then we collect our like terms. Notice here, x's are identical, but we can eliminate that because we've got -5 plus 5. So the middle terms eliminate. So in simplified form, our binomial times our binomial is x squared minus 25. What about the next one? Are you starting to see a pattern? When you multiplied y times y, you got y squared. When you multiplied your outside terms and your inside terms, you get -2y plus 2y, and they eliminate. What are we left with? Y squared minus 4. Same here. 2z times 2z, 4z squared, our outside terms, -6z, our inside terms, +6z, our last terms, when we multiply, -9. The middle terms eliminate. What are we left with? 4z squared minus 9. And the last example, 6 times 6, our first terms, 36. Our outside terms and our inside terms, -6d plus 6d, that eliminate. Our last terms, -d squared. 36 minus d squared. Do you notice anything? Are there any patterns? So you must recognize what the difference of two perfect squares is. What you see on the board is an algebraic expression that represents the difference of two perfect squares. Notice we have a perfect square here. X squared is a perfect square. 4 is a perfect square. And it must be the difference. It can't be addition. It's got to be the difference of two perfect squares. Recognize that you have the difference of two perfect squares, and then I'll explain what happens in order to factor. Do you remember in the previous slide, we simplified x plus 5 times x minus 5, and we got x squared minus 25. Factoring, we work backwards. We have a simplified algebraic expression. Now, what must we do? We must find what is multiplied by what. Notice we have the difference of two perfect squares, x squared minus 25. Notice in the second example, y squared minus 4, we have the difference of two perfect squares. When we work backwards, we get y minus 2, y plus 2. The third example, 4z squared minus 9. If we're going to work backwards, if we're going to find the factors, we obtained 2z plus 3, 2z minus 3. And 36 minus d squared, we have the difference of two perfect squares. If we're going to work backwards, we're going to find what is multiplied by what. We get 6 plus d, 6 minus d. Are you seeing a pattern here? But let's make sure you understand what to do. So first thing, whenever you're asked to factor or whenever in problem solving you need to factor, you've got to recognize that you have the difference of two perfect squares. That's the first thing you've got to do. Then place two sets of brackets to represent your two factors. One factor will be the sum of the two terms, and the other factor will be the difference of the two terms. And it doesn't matter which is which. You could have your two sets of brackets, and here a minus, and here a plus. It doesn't really matter. But one will be plus, the other will be minus. Then you find the square root of the first term. Square root of x squared is x. This will be the first term in each factor. Then I find the square root of 4. Square root of 4 is 2. This number will be the second term in each factor. So you can always verify to make sure that you do have the correct factors. So we found the factors of the previous example. How do we verify? We're going to use our FOIL method to make sure that we had that original expression, which was x squared minus 4. So when we FOIL, x times x is x squared. Our outside terms, x times negative 2 is negative 2x. Our inside terms, positive 2x. And our last terms, positive 2 times negative 2 is negative 4. We can collect our like terms. Negative 2x plus 2x eliminate. What are we left with? x squared minus 4. We just verified that those two factors are correct. There are more examples for you to practice. You might want to keep these steps in front of you when you're working on your factoring the difference of two perfect squares. So here are 5 examples. Try these at your desk and then look at what the steps are and what the correct factors are. Good luck. The first step is always to recognize the type of factoring you're going to use. There's no GCF, always verify GCF first, then look at the number of terms. There are 2 terms. When there are 2 terms, very often you're going to see that it is the difference of 2 perfect squares. And indeed, we have the difference, and x squared and y squared are perfect squares. Therefore, we can place our 2 sets of brackets immediately. The next step, and always do this one step at a time, one of these factors will be the sum of 2 expressions. The other one will be the difference of 2 expressions. How do we find those? We find the square root of the first term. Square root of the first term is x. This is the first term in each factor. The square root of the second term. Square root of y squared is y. That is the second term in each factor. Our factors are x plus y times x minus y. Did you get that? Recognize that you have the difference of 2 perfect squares. Place your 2 sets of brackets. One of the factors will be the sum of 2 expressions, the other will be the difference. Next step, find the square root of the first term. Square root of a squared is a. That's the first term in each factor. Then find the square root of the second term. Now here, be careful. You've got a numerical value and an algebraic expression. The square root of 4b squared is 2b, and 2b will be the second term in each factor. The factors of a squared minus 4b squared are a plus 2b times a minus 2b. How about this one? 81x squared minus 16. Now, after you do a few, of course, you can skip some steps, but I still recommend that you place your 2 sets of brackets, then place a plus and a minus. You're going to have the sum and the difference. Then you find the square root of the first term. 81x squared is 9x. That is the first term in each factor. Then find the square root of 16. The square root of 16 is 4. That is the second term in each factor. So the factors of 81x squared minus 16 are 9x plus 4, 9x minus 4. Get into the habit of doing these steps. First of all, check to see if you have a greatest common factor. There isn't. Then count the number of terms. You have two terms. Recognize that you have the difference of two perfect squares. After you've recognized this method, place your two sets of brackets. One factor will be the sum, the other will be the difference. Find the square root of 36b squared. That happens to be 6b. So you're going to have 6b plus, 6b minus in each of the factors. Then you're going to find the square root of 25c squared, which is 5c. Your factors are 6b minus 5c, 6b plus 5c. And here's another example for you. But remember, always verify if there is a GCF first. Did you notice that 4 is a factor that's common in both terms? So we place that GCF outside the brackets, we place our brackets, and then we divide 4 into both terms. 100x to the power of 4 divided by 4 is 25x to the power of 4. And negative 4y to the power of 8 divided by 4 is minus y to the power of 8. So it's factored, but it's not fully factored. We recognize inside the bracket that we have the difference of two perfect squares. Now, don't forget that GCF. Always place that GCF in front of the bracket. The method for the difference of two perfect squares, we place our brackets, we place our minus and our plus, and we find the square root of each term. Square root of 25x to the power of 4 is 5x squared. And the square root of y to the 8th, you keep the base and you divide the exponent by 2. We are now fully factored for that question. 4 times 5x squared minus y to the 4th, 5x squared plus y to the 4th. So here are your steps for factoring once you've recognized that it's the difference of two perfect squares. I hope all of this has helped you.